What are we on, 7.4? I'm going to just have that out. All right, cool. All right, let's say it says find the area bounded by the curve f of x equals x cubed plus x squared minus 6x dx between x equals 0 and x equals 2. Okay, so we got to break in the action here because we got to know something. And here's what we got to know. Yesterday we talked about this idea called the what? Fundamental theorem of integral calculus, that said that if this is f of x, the area is the integral from a to b of f of x dx. Okay? But now we have a new situation, and this problem is giving us a new situation. And here's what the situation is. What if this is f, and this is a, and this is b, and I have this area that's underneath the x-axis? Okay? Well, that area is equal to, are you ready? The opposite. It's actually negative. Okay, so if I did the integral from a to b, I'd get a negative number. So I have a couple choices. I can negate it right from the beginning because I know that it's underneath. Or I could, how did we do it yesterday? Well, then I don't need to make it negative because that will change its sign. Or last but not least, which is what most students choose because it's the easiest, is that it's the absolute value of the integral from a to b of f of x dx. You remember absolute value? Makes everything positive? Those big lines? No? Okay. Let's just quickly do absolute value. Absolute value really is the distance something is from 0. So like the absolute value of negative 3 is 3 because it's 3 spaces from 0. See what I'm saying? So whatever's in those absolute value signs comes out positive. So that's what this is, absolute value. Okay, so when we get a function and we're asked to find the area, you know, that it bounds, from now on we have to graph it. I mean, unless you know that it's above. Do you? You wouldn't have a clue what it looks like, would you? Okay, so because you don't really know how to graph, I'm saying that in the nicest possible way. I'm your teacher, so it's sad but true. Then we got to graph it. Okay, so I'm going to go on here. Now I'm going between what and what? 0 and 2. So I'm not doing negative 10 to 10. Okay, I might do like negative 1. Oops, what am I doing? Window. I might go x is negative 1 over 2, 3. I don't know. You know what I'm saying? Maybe I'll keep the y. I don't know how big up it's going to go. Not sure. Then I'm going to go y equals, get rid of all that hubbub, and go x cubed plus x squared minus 6x, and I'm going to graph that. Okay, so from 0 to 2, it's entirely underneath. Do you see it? So in these problems now, you have to graph. So That's part of your solution, the graph. It doesn't have to be neat. It just has to go, 2 and like that. And you go like that. Is that all right? That bit is underneath the x-axis. And I might put an x and a y. So your solution is going to get a mark for doing, getting the graph. You can go GC if you want, or who cares? You could have known that. I mean, really, you could have put in 0 and 1 and 2 into this equation and figured out these points, and then you would have known it was underneath. It's not like you have to actually graph it. Okay? All right, so there it is. There she is. And so I'm going to say that this area is equal to the integral, and now I'm going to go, instead of 0 to 2, I'm going to go 2 to 0, or you can use absolute value, you can do whatever you want, of x cubed plus x squared minus 6x dx. And because we spent too much time today talking about things, I'm going to do it on my calculator. Is that okay with everybody? Not hard. All right. Let's go to, how much time?